So chapter 3 content with numbers. So here we need to understand what are the data types. Okay, and data type is very important, especially nowadays we are at the age of studying the data science, right? So we are at the age of to study data science. And data science actually is one of the very important field, right? We used start to study computer science, but now we actually having the new term called data science, and data science becoming a new emerging major in college, right? Some people do major in data science, and data science actually it is equivalent to computer science plus statistics. Okay. So basically, you collect data and analyze on it. It's called a data science. Okay. And the first step of the data science is to create data, right? Or collect data. Okay. And then, for example, like if you actually take the SAT exam, right? If we want to study the SAT exam, so students go to the exam and they bubble it, right? They bubble it like this. So you get A, B, A, C, D, E, A, whatever, right? That's the kind of bubble you actually see on the score sheet, right? And then they turn in this bubble sheet to the SAT college book, right? And then they use a scanner to scan through this SAT form. So they read it, right? And it become A, B, A, C, whatever your answer, right? But some of them actually may become this, okay? You may have a answer sheet, there is a bubble. You actually fill out like this, right? And you are intended to do B, but actually the reading may be unanswered, right? Maybe unanswered. Or maybe you have a bubble like this, right? But somehow you just do this. For some reason you grade this one, but also the other bubble also being touched. And somehow the scanner read in and read a C instead of a B, right? So in the collecting of the data, there are errors. So when you collect the data, there are errors, and this one actually is called raw data, right? The bubble sheet that is the answer sheet that with a lot of pencil bubble, those are raw data. Raw data converted to the ABCD things, there might be error. And this error is one type of error that the answering error, and you may need to actually collect it later, right? You may need to collect it later, and using human eyeball to review it, right? So there is a SAT score review process, right? That's a score review process. That's number one. You may need to review it. Number two, there might be some form, and you put in your name or address. Say you write in Eric, right? And for some reason it become it actually read it wrong. So it actually the scanner scan in, but it doesn't read in ERIC, but it read in ERJC, right? It's possible. So it's possible that actually they make such a mistake. Okay, so number one, you create data, and number two is actually cleaning data. Okay, before we do anything else to actually look at what are the data and what we can calculate the score. We need to clean the data. Number 2, that's step 2. Okay, and then we convert the raw data to data. Okay, so when we connect the raw data to the data, it really means that the bubble scanning, it maybe is some sort of reading. So there's a scanner, and scanner really scan in that how much area it is, and it make decision on should it be B, C, or D. Once you have this data, that is already processed the data. Right, let's process the data. So from raw data to cook data. Okay, so it actually cook means that it's already in A, B, C, D, right? But before we have the cook data from the raw data to here, we need to determine the data type. Right, we need to determine the data type. And this data type right here, if you are in the multiple choice, it is A, B, C, D. Is a single character, right? Actually, single character. So before we determine that single character, you need to know about the data type. So this data type is actually character, right? And in Python, it's called string, single character string, right? So let me clear it. Okay, so step 1, you need to create data. Okay, after you create the data, you need to clean data. Right, and then you start to actually clean data. You may get your raw data, right? And your raw data actually start to actually get information. And the first piece of information from here to here, this one you can consider it is cook data. Okay, so here you have the raw data to cook data. So cook data is from this bubble to A, B, C, D, right? And here you have 2 types of data. The data have used 2 types of data. One kind of data is the qualitative data. The other kind is called quantitative data. Okay, so something like A, B, C, D, I would say this is actually some sort of quantitative data. I'm sorry. Yeah, this is quantitative data, right? It's quantitative data. And what is qualitative data? Qualitative data maybe is something like there's a phone. SAT may not have it, but your score report would have it, right? There will be a field, and then your teacher fill in some information about his student, and she may write down smart kid. Okay, so this smart kid actually is what? It's not 0 to 100. It's not A, B, C, D, E, F, right? A, B, C, D, F, right? It's not that grade, right? And it's not 1, 2, 3, 4, 5 for the GPA, right? It is something called smart kid. So smart kid is not quantity. It's not quantity. So those kind of information actually is qualitative data, and qualitative data usually is written down in string format. Is that okay? Hello? Is that okay?
Yeah.
Yeah. And quantitative data usually can be 0 to 100, A to F, and 1 to 5, right? Those are quantitative data. So quantitative data usually is like the score you get or the answer you enter, right? Those are actually quantitative data. So that's good. Okay, we get that. So now we read in raw data, we convert it to cook data. Okay, and cook data is not information yet. Okay, cook data, let's actually change it a little bit. Okay, So we got raw data, right? We got raw data. Let me erase them. Raw data is the bubble, right? And as I say, you enter the data, you may have quantitative, you may have qualitative, right? So you go into cook data. Cook data is a firm, A, B, C, whatever, that you bubbled, okay? So in between them, you actually have qualitative data or quantitative data, two kinds, right? So from cook data, you generate information. So what is information? Information is we have a answer key, A, B, D, D, okay, to grade you. So it can become your math section, 760, English section, reading, writing, right? ERWC score, 750, right? And then sum together, that's 1510, right? These three are actually information. They converted from data to information already, a score. These are already information, right? And these are first information. And this first information we collected to our computer, right? And then this one, actually totally, this year we had 2 million of students. So we create a big file. So here, from here, let me clean everything, okay? So number one, we create data. Number two, we clean data, right? And after we clean data, we actually create, we will get raw data, okay? We got raw data. And raw data converted to cooked data. And cooked data generate the information. And information based on statistic. Okay? This one is 760 plus 750. So these are actually integer type, right? These two are integer type. So two numbers, you get it, and you create statistic. Statistics, so you get a table, right? You'll get a table. So out of the 2 million students in the United States who took SAT this time, so they are math 800, maybe 200 people, right? 790, maybe 1,000 people, right? 780, that maybe 13,000, right? Something like that, okay? So these are actually using the statistic. We get a table like this, right? We get a table like this, right? So that actually statistic. So we will see some information like this, right? 800 for math score to the lowest one, 200, and mean value maybe say 400 or something. I don't know. Okay, so that's statistic. Now this statistic data we convert it to information already, right? That's the information. And we create a statistic, and this statistic sent to some school, say Princeton, right? And Princeton use this one to make decision. Let's pick 760 as the cutoff line. We only pick these students for our math major. Is that okay? So from the information, we can based on that to actually what? Make decision. Right? We want to make decision. But when we want to make decision, we need to have a cut-off point. We need to know about cut-off point. And this is a cut-off point. What should we use for cut-off point? Maybe 1%, maybe 2%, right? So the number is fixed, but this is 760 every year. It may go this way, may go this way. It actually not a fixed number because every year the statistic may be different. Every test, the test trends are different. So we need to actually kind of adjust every time to actually make up this table and see where is the cutoff point for 2%, right? You need to look for that. So then every time that depends on the statistic, okay? Is that okay? Based on statistics, we need to make decision. So the whole thing, actually from creation of the data, right? And then after we make decision, we send out the admission later, right? We send out the admission later. That's the last step. So from creating data to make decision to actually finish the use of the information, that's the life cycle for our data. Is that okay? That's the life cycle for our data. Is that okay so far?
Yeah.
Yeah. So in this whole thing, we have different kind of data. We have a bubble. We have a ABCD, right? We have a information. We have 760, 780, the score, and then we actually will make decision on where to cut it, right? So there are statistics about 800 and then number of people, right? 200, 790. So there are more data over here. There is a table, right? And then there is a decision we made. So actually admitted or rejected, right? Or waitlisted. So there may be a number called ARW, something like that, okay? So these are all the information involved, data type involved here. So here, this one may be a character. This one may be an integer. This one may be 2 integers. So 2 integers. So integer, score, and number of people in integers. Then there's a number of percentage standing on certain score. So there's a 40-point number over there. And later you have make decision. There's another character again. Is that okay? So the whole SAT processing step, we have many data involved, and that's our counting with data. Is that okay? We count the data, counting with the data type. That's a counting with number. Okay, so here we have different data type, and data type is used to represent your data. And data in Python can be several types, right? Several types. And data sometimes is called data, sometimes called information, sometimes called decision, sometimes called knowledge, sometimes called AI rules. Well, it depends. Depend on actually how much process you have, and also depend on the quality of the data. Okay, but here let's assume that everything is called data, but the data itself it will still have different name. Okay, it will still have different name. So this chapter we try to teach you how to process data, basic processing of the data, and those are data types. Okay, and then actually understand the fundamental principles of how number being represented, and we will use the math library and then trying to understand an accumulator program pattern. Okay, and we will write numerical data. Okay, so that's this chapter's purpose. So numerical data type here in Python language, so far we've started to learn something, but basically there's only 3 types of data: Boolean, string, and a number. A number has 2 types. Number has integer type and have float type. Okay, we talked about this already. So totally you can think about 4 data types, but it really has 3. One is logic data, that's actually Boolean. Okay, second type is actually numbers, the number you have integer and floating point. And then the next one is text data, and this data we call it string. Is that okay so far? Helen, is that okay? Can you understand so far?
Yep.
Yeah. And then out of these three basic data, we have 5 more types. These are compound data. So compound data is a collection of data. So today we more focus on these 3 basic ones. Okay, we will touch the compound later. Okay, compound data is actually collection of the basic data. Okay, so here we have numerical data type. Okay, and they are integers. That's a whole number called integers, and decimal fractional. That's 0.25, 0.10, 0.05, 0.1. They are decimal fractional number. Okay. So in computer, the whole numbers and decimal fraction are represented quite differently. Okay. So we need to determine what type of data it is. And when we do input, enter a number, it will give you a string. And then we do use the eval function or integer function or floating point function to convert them into the right data type. Okay. So here we have C language data type. There are so many, right? But in our Python, there are only 4 types: integer type, float type, Boolean type, and also the string type. Okay. So whole number are represented using integer. Okay, and they can be positive or negative or 0. Okay. So here actually you have a integer, but in Python language, a integer actually is a object. Okay, it's an object. Any data in Python, they are all objects. So it's different from C language. C language, you actually have the storage, just put the number into there. Okay, but Python is more complicated. They are object. We'll talk about this feature later. Okay. It's different from the C type data. So number that can have the fractional part, we call it floating point number. And we call it floating point number just because that if we have a number called 0.01, right? So this one times 10, it really means your decimal point move to the right for 1 digit, it becomes 0.1. Okay? If this 0.01 times 100, it actually means that 0.01, it moves 1 digit, 2 digit, if the decimal point go to here, so it becomes 1. Is that okay so far? So same thing, if you are 0.01 divided by 100, that really means your decimal point move to the left 1, 2. Okay, so it becomes 0.0001. Okay, so that 14 point every time is like your decimal point by multiplication, it will move. You move, right? You move from here to here. You move. So that is a 14 point. Is that okay? So 14 point number which is stored in your computer, somewhat like your scientific notation. Okay, somewhat like your scientific notation. So every time you times 2, you will just move the decimal point left, right. Okay, something like that. Is that okay? And you store into the computer, it really is your number and the exponent being stored in the computer. That we call it for different data. Is that okay so far? Is that okay so far? These are different from the integers. Okay, so these are 2 number type. Okay, so you can do type and then you can do 3 and type it, print the type. Okay, so let's see this one on computer. Okay, print up the idle. Okay. Let's see, a equals 3.4, right? And then we do print type of a. I think I showed you this before, so it's a 14-point type. And then we do I equals 4, and then we print the type of this number I. It would be integer, right? We put g equals 3 plus 4 I. Okay. See, actually, e equals complex. So there is another type called complex number type. Okay, but complex is not a basic type, so we do not talk about it right here. But basically, it is also a data type that actually is included. Okay, plus g3 equals g plus 3. Okay, that actually is possible. Okay, so that actually here we talk about this different data type. Okay, but basically so far we touch only the floating point type and integer type. So integer type means a whole number. Floating point type means a number with fractional part. Okay, but they are more advanced data type called complex type. Okay, so those are the data type available in our Python language. Okay, so that's numerical data. And because the numerical data sometimes it will create the approximated data, so it may not be exact. So usually, for example, like if we have 3 divided by 7, Helen, what would be 3 divided by 7? How much? Helen, hear me?
Could you give me a second?
Yeah. What should be the number?
About 3.42.
How much? 0. What? About how much? Hello?
About 0.42.
5 divided by 7 would be 2 divided by 7 would be 6 divided by 7 would be okay. Zoe, have you learned this before? So you have a divided by 7. Okay, so 1 divided by 7, it is 0.142, right? Blah blah blah. Continue. 2 divided by 7 would be 0.285714. Blah blah blah. 3 divided by 7 would be 0.428571. Continue. Okay, but basically a divided by 7 it would be 14285 and rotating. Is that okay? Is that okay? So if you have 1/7, you should start from here, 0.14257 and rotating. You can use calculator, you will see it, okay? If you have 2 divided by 7, you start it from here to this rotating. Is that okay? Hello, is that okay?
Yep.
Yeah. So you can figure out all the number, okay? And what kind of number these are? 1/7, what kind of number these are? What that is called? It's called. Is that a rational number? It's a rational number, right? But the fraction actually is infinite number of bits, right? That's because that when you do actually say 1 divided by 7, it becomes 10 divided by 7, so it actually get what? Actually do 1 and then 7 and it becomes 30, right? So 1 changes to 30, right? So you continue that, you will figure out there's a remainder and that pattern will repeat. Is that okay? That pattern will repeat. So here if we try to use 10, actually here let's do 11, right? So let's do 1. Okay, let's do 1. So you'll be 0.0 become 100, and then here we have 99, 1, right? So you will actually become something like this. You will repeat something like this. Is it okay? So depending on your divisor, actually the number that repeat will be different. Okay, will be different. But what we see right here actually is what? You are repeating the pattern and they are fractional number. Is that okay? They are something with fractional number. So this kind of thing you cannot actually represent it by using your integer. There's no way that you can represent it by integer. Okay? And also you do not have the exact number. You do not have the exact number. So the irrational number or some of these the so-called rational number, some of these rational number or irrational number like square root of 2, they will not have exact number to be stored on computer because you are going to have what? You are going to have 0.1425, 2857 and 14. It will continue for infinite number of digits, but you got to cut it somewhere. You got to cut it somewhere, otherwise you cannot represent it in your computer, right? Your computer storage fixed number of bits, so you got to cut it somewhere. So there's can only be a approximation for those real numbers. Is okay? Can only be the approximation for the real numbers. So these are approximations. So square root of 2 or 1/7, they don't have exact number of bits. But if you have 1 divided by 5, you will have 0.2. That is the exact number, right? That is the exact number. You can represent it as an exact number. But if you have a rational number like 1 divided by 7, or an irrational number that actually square root of 2, you don't have the exact number. You can only store a approximation of the number in your computer. Is that okay?
Yep.
So because of that, your floating point number actually may lose bits. Because it's not exact. It may lose bits. Okay, and so it actually is what? Only approximation. Okay, remember this word. Floating point number always just approximation. It's not exact number. It's not an exact number. So sometimes use a 14-point number, be careful, okay? Especially you check for the two data are equal or not equal, you may be in trouble, okay? So that is actually our 14-point number, okay? So you do addition, you do multiplication, you do division. So here, division has two types. If you do 10 divided by 3, this is called 14-point division. And you will get 3.3 something, okay? The other type is 10 double slash. This is called integer division. And you got 3. That means you have 10 divided by 3. You will be 3, 9, remainder 1. So this number is your integer division. So you have A divided by B. You got a Q, right? And here BQ, and you have remainder. So A equals B times Q plus R. And the Q quotient, is your result for your division, A divided by B. Is it okay?
Yeah.
Yep.
So when are we going to use this one? Like you getting your change, okay? Getting your change, you may need that, okay? You may need that. So let's try to write a program right here, okay? Let's try to write a program right here. So let me give you like $2.56. Can you tell me how many $1 bills, how many quarters, and how many dimes, how many nickels, and how many pennies? Okay, this time I don't write program to show you. Can you write a program to calculate just this simple number, 2.56? How many bills, $1 bill, you will have if I give you such exchange? How many dollar bill I should give you? How many quarter I should give you? How many dimes I need to give you? And how many pennies I need to give you? So if you can use a dollar bill, you don't use a quarter. That means that you cannot give me 556 pennies. Then that's not good. I won't. If I can get a dollar bill, I will want to have dollar bill. If I cannot have dollar bill, I want the quarters first. If I don't get the quarters, I will get a dime first. Okay. So priority is like this. Is it okay? Can everybody try to think about it and then write a program? So I'll give you 2 minutes. After 2 minutes, I'm going to check your data, check your program. Is it okay? So bring up your idle, think about this problem. This one, I don't show you how to do it first. I just want you to get started. And later, I'll give you answer. Is it okay? So let's do this one. I give you 2 minutes. Can everybody bring up your idle and start to solve this problem using division, integer division? Is that okay? So any arithmetic is okay for you to use. And there's a percentage sign. Percentage sign called remainder. So what it is here we have this one. We have, say, 17 divided by 5. Okay, so 3, 15, remainder 2. So this one called 17 divided by 5. You get 3. This one called taking remainder. So 17 taking remainder by 5. You get 2. Is that okay? So what you can do right here is $2.56. I want you to give me the dollar bills, how many of them. I need to do how many quarter, how many time, how many nickel, and how many pennies. And what I can give you is plus, minus, division, integer division, and take modular, these different operators. Is that okay? James, is that okay?
Yep.
Yeah, can you get started using your idle to do programming? Eventually, you need to print out how many dollar bill you will give me, how many quarter you will give me, how many time you will give me, how many nickel. So giving change to me, okay? Isa, is that okay?
Yeah.
Is the problem clear enough for everybody? How about Zoe? Is that okay?
My idol has some issue right now, but
Okay. Try to bring up, okay? I give you two more minutes. I talked about 2 minutes. So I'll give you 2 more minutes to work on it, okay? And I'll check. Helen, is that okay? Hi, Helen, hear me? Is it too hard or it should be equal? It should be okay, right? Because it is only arithmetics. Mm-hmm. So here involve the data representation and data operations. Okay. You work on bill first, dollar bill first, right? You work on this one first, and then quarter, and then nickel, and then at the end, pennies. So the answer apparently would be $2, 2 nickels, 0 dime, 1 penny, 1 nickel, 1 penny, right? The answer we know is you can calculate. It's not hard to know. But I need you to do it in program, not just getting the number, okay? So Ethan, are you okay? Can I start with you?
Oh, I'm not done yet.
You're not done yet. How about James? Are you done?
I don't really understand. Could you help me, please?
I say I will give you $2.56, right? And then you need to tell me how many $1 bill I will get, how many quarters I will get, how many times I will get, how many nickel I will get, how many penny I will get. The problem is that is, right? Is that okay? Is that clear enough?
Yeah, but like I don't understand how to do it.
That's your problem. I give you the problem, you need to solve it, right? It's not something I should tell you. It actually is you need to find the answer. We are doing programming. You need to find how to find this answer, right? Is that okay? problem is give you a money, the change amount that you need to, I will give you, right? And then you need to convert it to how many bills I have. You think about today, you are the guy sitting at a checkout site, right? And you figure out, okay, this gentleman, I need to give him this much change. And then you open your counter, right? And then you are counting, right? You're giving them the dollar bills, you're giving them the quarters, right? Well, the guy need to figure out how to give them how many dollar, how many quarter, right? And now you do it in computer. Is that okay? Okay, so let's talk about how you can do it, okay? Before I check in your data. If you guys don't know how to do it, let's think about this. Let's actually look at here, okay? So $2.56, okay? That's the goal. Hi Zoe, how many dollar bill? How can you decide how many dollar bill you need to give me? So just answer this question right now. How can you determine that how many dollar bill you need to give me?
You just divide it by 1 and take, you can't really take remainder, but
How can you do that? You have two integer division, you have the floating-point division. So how can you determine the dollar bill? So let's assume that this number is called C change, right? So C equal 2.56. So now I want to have dollar bill. So give me B. B is dollar bill. From C, how can I calculate the B? That's the problem, right?
just C divided by B.
No, B is the answer I want to have.
Oh.
So how can you do it? I give you a hint, right? Here I do 256 would be easier than 2.56. So I convert it to cents. So here I do 256 divided by 100. I'll get the number of dollar bill I should have. Is that right?
So you do C times 100, and then
C times 100, right? And then you take integer.
yeah, okay,
That become your cents, right?
yeah.
Yeah. And then that cents divided by 100, but need to do integer division. Because you do 256 divided by 100. Here 2, this is the dollar bill you get, right? Is that okay?
Yeah.
And then you take remainder, that's the remaining amount. You need to find the quarter, dime, nickel, and penny. Is that okay? And you do it one by one, one by one, one by one. From dollar bill to quarter to dime to nickel to penny. Is that okay? Can you do that? How about Ethan? Can you do it?
I'm confused on dimes. I've done quarters and dollar bills, but I haven't done dimes.
One dime is 10 cents, right?
Yeah.
Yeah. Every step is almost similar. So think about it. Dime is only 10 cents. Okay, since you are working on the dimes, can you show me your a program right here? Okay. So then actually I will actually quit sharing. You share, okay? Ethan, you show me your screen, okay? Ethan, can you show me your screen? I say convert it to cents, but you do not convert it to cents. 256 is actually a fractional number. You are still fighting in fractional number. So the first step already wrong. Okay, so what should we do? The second step, we kind of use this, okay? So here, number one, we rewrite it, okay? This one actually not going to help us. First one, we have a simple number called cents. So this time, the number of cents should be 250, right? So here, before we go to this one here, we should do change amount will be equals what? Equal 14 point number, right? And this 14 point number coming from where? Input, right? So I need to ask for the number of the change. Okay. So once I got this change, I should do what? Convert it to integer. But what convert it to integer? You change it to time 100. Right. This one actually is what? Converting your change to cents, right? After that, this is in cents. So here we would have dollar bill. Dollar bill should have this number of cents divided by 100, right? So this one should be equals 256 divided by 100. That will actually give you the dollar bills. Right? And once you get the dollar bill, and then your cents, your remaining cents should be what? Should be your cents taking the remainder by 100. So that would be 56. Because that $2 already been represented by the B already. Okay, so we got the remaining cents, it will be 56 cents. So this one I have a quarter. My quarter should be what? My quarter should be my new cents divided by 25. So that actually should be my 56 divided by 25 cents. That will give me 2 quarters. Right? That will give me 2 quarters. Okay, that will give me 2 quarters. And after I get the 2 quarters, then my remaining cents should be C, take the modular by 25. Okay? And I continue for time for everything else. Is that okay? At this moment, this C should be only 6 cents. Okay, I stop right here and you continue. Is that okay? Lisa, is that okay?
Yeah, thanks.
Do you understand what I'm doing?
Yeah.
How about James and Helen? Can you understand? Can you understand, James?
I don't really get how you did that. Like, I can copy it, but I don't know how you could think of that.
Okay, Helen, you show me your screen. Show me your screen. Yes. No, you need to open a file. Not doing it here. Open a file. Yeah, create a file. You should create a file, not open. You should cancel. Cancel. Don't do anything. Cancel. Okay. File, new file. Yes. File, save as. File, save as. Go to file, save as. You go to a directory where you store your program. Yes. So here actually go to tab. Go to there. Yes. Double click on that. Here you create a chapter 3, please. No, not yet. Here, over here, you create a chapter 3. No, not yet. Don't move, okay? Here, can you create a directory called chapter 3 over here? Right click, please. Come to here, right click, new. Right click, new. Hey, right click, move down to new. Don't move. Too high already. Go down. Your cursor go down. Right click, go down. Hey, go down. You see the menu, you should go down. One moment. Let me show you, okay? Let me show you. You actually did it wrong, okay? Let me share here, okay? Okay, so here, let me quit this one, okay? So here, for example, if I go to my here, so in idle, here, first one, you need to go to your directory, create a new folder. So this one is chapter 3, right? I create chapter 3. So here on my idle, I do new file, create new file. Then here I do save as, right? And I go to the directory I have. So you just by listening, you are not going to learn anything, okay? You have to work on it. So let's do this one. You go to the directory here, come to here, right? Go down to chapter 3 over here. Here you actually create a file. Let's go call it change. And then you start it from here. You start it from here, say change. So here I say it's change equals, you do input, right? And here you do enter the change, okay? Don't just copy code every time because you need to think about it, okay? If I give you the code every time and it's not programming, you never actually think about it, it's not programming, okay? So here I have this one, I converted to floating point. I cut a change, but I want to make it in cents. Okay, so this one, the change I get in, I should do convert it to integer by what? By the change times 100. I convert it to change, right? And then I need to do $bill. So this is a change. Actually, need to integer division by 100. So that one is actually do what? Actually 256 cents will generate $2 bills. Okay. Then you do C equals C modular by 100, right? That C will be 56 cents. Okay, so something like that. So let me do this one here. Let me post the program over here so you can download. I think that would be a little bit faster, but I don't want you to always rely on my code, okay? Then you are not going to learn, so I just do it up to here. Okay. So I change the P1, post it here. Is that okay? I will also post it on my Facebook site, okay? So here I bring a messenger, and I will also post some here, okay? Can you download the file from where it is? If you don't know how to do it, please download, okay? If you are able to do it by yourself, don't download, okay?
Dr. Chow,
Yes?
could you come look at my program, please?
Yes? Okay, one moment, okay? I post it.
Okay.
Okay, now I stop sharing. You share, please.
So, I put in the program and then I ran it.
You need to print.
What?
You need to print. You print nothing, you won't get it.
Okay, so where should I
So you need to print, right? You got B, you need to print B.
be?
You need to print B at the end, at the very end of the program. You need to print B.
Like in between each one.
At the very end of your program, you need to print B. Okay, you calculate, you need to print, right?
So at the very end?
Yeah, you need to print it. So one moment, let me do it, okay? So here, after this, you need to print your...
Okay. Oh.
Why do I
print
need int
B.
parts? Because you
Hey, don't move, let me do it, okay? I show you this one and you do it by yourself, okay?
Okay.
integers are just anything.
Okay, I just do B, right?
Oh,
You
okay.
calculate the B, you need to print it. If you don't print it, you don't get it,
Oh,
right?
hold on. Yeah.
So let's run this one.
Coding that's
So here the change is 2.56, right?
Mm-hmm.
here.
Is that okay?
Okay. Yeah, I see it. So let me. So
You continue, you need to do $B or print quarter, print whatever.
okay. Thank you. Yep.
And you continue, okay? I'll check with you later. Okay, how about Ethan? Are you
Why
okay
does he
so
have
far?
a percent sign? That's right.
I still need a print.
Okay.
Yeah, I get that, but why percent?
How about Zoe? Are you okay?
C is for.
Can you show me your one?
Yeah, but what's the percent for? The remainder.
The same is for taking remainder, okay?
Okay, so how? So you have another 10.
Percent is taking remainder.
It's going to be 3. Because divided by 3 plus remainder. Well, why would we want a remainder? Yeah.
Hopefully.
Don't know what you want? Okay. So like he says I'm giving you $2.56. When you get change for that, how many dollars bills do you get? $2. Exactly. And then you get what along with that? 56 cents. Right. So this is gonna tell you how many bills you're gonna get. And the C is gonna tell you how many cents you have left over. That's change? Yeah, that's the remainder, that's the percent. Okay, does that make sense? Yeah. This is how many bills. This is just. But I thought he just wanted to know the bills. Why does he want to know the remainder? He never said he wanted to know the remainder.
$2 bills. Oh,
okay.
this is beautiful.
Yeah, okay. So this is Zoe, right?
Yeah.
Can you? Hey, why you can create a new file? How comes you have the triangle in the same file?
Oh, I think it was a different.
Now it's actually in one same file called main.py, right? So
Yeah.
why don't you create a new program? Is that okay?
Yeah. So should I just?
Copy, create a new file. Create a new file first, and then copy. New file, Python file. Yeah, it's called change. CHANG. Yes, and then copy this one to there. Go to main. Copy that one. Yes. Is that okay?
Yeah.
So wrong it. Wrong. Wrong. No. It's on top. On top is a wrong. Yes. Click wrong. Yeah, go down. Go down. There's a wrong. Okay, one moment. That's why I prefer to do idle first before you can handle this PyCharm. PyCharm is good, much better, but at this moment
my idle wasn't working
yeah,
for some reason today.
it would be easier to handle. You know what I say? So here you choose a change. And you wrong, right? Enter the change amount. So here you type 2.56. So $2 11 times is wrong.
Oh.
Right? It should be you should get quarters, but you did not get quarters.
Oh.
One. Also, you
forgot
actually,
quarters.
yeah, you forgot quarter. You have to deal with quarter
Oh, shit.
also. Okay.
Yeah.
So number one, you got your change, but this one still in not in the right format. So here you should have conversion of that one to integer. If you don't convert to integer, it still be a floating point number. It's not in terms of cents.
Oh.
Is that okay?
Yeah.
C is still a change, but it's actually a change in terms of cents. Is that okay?
Yeah.
And then you divide by 100 at 0 double bill. That's okay. Then next one, if I follow the way you did it, you should have a quarter, and that quarter should be your actually your cents. So here you are doing cents, so you actually do cents to the remainder of 100. But this one is not good, okay? Because later when you use that for this, your cents still be 256. That's not correct. That's not correct. So better way is over here. You need to adjust your cents will be equals your original cents. Tell remainder by 100.
Okay.
What does that mean? What does this mean? This means here.
You take the change divided by 100, but the percent is the remainder.
Yeah.
So
Basically you have 256. You divide it by 100. That's 2, right? That's 2. So this one tell you that's a $2 bills, and 56 cents are the remaining amount you are going to take by quarters, by times, by nickels in combined. Is that okay?
Yeah.
Yeah, and then here you continue from here. Is that okay? These you all need to change, okay? Anything below, let's see, need to be changed. Okay, I'll let you continue to work on it, okay? So now how about Ethan? Can you show me?
Okay.
No, what's that for? Hey, the last one, why do you need the last one? Your sense already be presented, yeah. And where the last one, how comes you see comma, you have one extra comma? What's that for? Yeah. And every print line you have the quarter. Why do you need to have the remaining sets be printed? Yeah, that's okay. Wrong it. Before we go, save and run. Save and run. Yeah. Look at US is okay, but how comes that change for 50 cents? I'm not asking for change for 50 cents. So that is, I mean, your discretion is It's okay, but unnecessary. Well, nobody asks you this. I just ask you enter the number, how many dollar bill, how many cents, how many quarters, how many times, right? I don't need you to print this. It actually doesn't help me at all, right? Is okay? Unnecessary information. So actually, I even don't need the change in. I just need the equals times or whatever. You want to say? Does that change in tell me any new story? No, it doesn't tell me any new story. I don't need that. The first one you have dollar bill, that's fine, right? Second one quarters. Third one time, and then equals and cents. Is okay? Hello, is okay?
So should I just for this one?
Just quarters. I don't delete quarter. Quarter is fine. Yeah?
That?
Yeah.
Okay.
I don't need to have a long description before, so you convert it, okay? How about Helen? Come back to Helen. Helen, how are you? Can you show me, Helen? Yeah, you're doing printing, okay? I don't bother you. You continue to do printing. So look like everybody are better now. Is that okay so far?
Oh, you need to print.
Is that okay? So Helen, you continue, okay? Is that better so far?
Yeah.
So how about here we are doing the Nichols whatever, right? So how about it here? I show you another problem, similar problem. I don't do this one, okay? I don't continue this one. I will give you the answer after class, but not doing this. Here I actually create a new file. This new file actually, let's call it actually called time. Okay. Let's go call time. Okay. So this one I'm going to save it as time.p1. Okay. So over here I'm going to actually do time person. It should be some sort of so get current time. So get current time I need to use I don't want this one. Okay. System timestamp. Current timestamp in Python it actually time. Okay, time. Let me see. Time module, okay. Since epic time, okay, good. Copy this one, okay. Put it on here. So from time module, import time module, so time, I get a timestamp, okay. So there's a timestamp that is, and I'm going to actually convert this one to integer. So that will be a timestamp, okay? So this timestamp actually is what? It's a timestamp actually is the 1970, actually 1970, and then January 1st, okay? It is the January 1st, and it actually also 00 a.m. Okay, in the morning. Okay, in the morning. This is 1970 years, second since there. Okay, so let me run it. Let me see. I actually print it. Oh, I forget to print it. Sorry. So here, let me do. Yes. Okay, let's print yes. So it's like this. Okay, so I already converted to seconds. So it's only like this. Okay, so this is total second. This one actually is what? This one's a total second since 0:00 a.m. and then it's January 1st, 1970. Okay, so that's the total number of seconds since the time. Then here, the first number I would like to calculate is the total seconds since this morning 00 a.m. How can I get this number, the total number of seconds since the union? So I need to do what? I need to do days. So one day, how many seconds? One day is actually 366 times 24, not many seconds, right? These are not many seconds. So here I would have seconds. Total number of seconds since this morning would be the timestamp. Take remainder of this. So basically here I have a huge number 159843525 divided by this many seconds in a day. So whatever number it is, I don't care. There's a remainder, say this much. This number would be the number of seconds since this morning. Is that okay? Hello, is that okay?
Yeah.
Yeah. But there may be a time zone problem, so that's actually try this one. So that's the total number of seconds since this morning, right? And then I'm going to do hour, current hour, how many hours passed since this morning will be the total number of seconds divided by this this number of seconds, right? So say since this morning I have this many seconds, right? I divided by 3600, right? I should get maybe around 4, right? And 1. So 41. Let me see. Oh no, only 4. This is this is yeah. So it's before and then we went this 60 seconds. Okay. So that's a 4 o'clock in the morning. So past 4 hours. So that's the hour I have. Okay. And then I do have my seconds. The remaining second would be my seconds. 10 modular by 3600. Okay. And then I will have my minutes. That would be my seconds. 10 modular by 60. And then here let me call minutes. Okay. And I would have my remaining seconds equals seconds 10 modular by 60. So now I have my hours, minutes, and seconds. So here I will have my hour, minutes, and seconds. Let's run it, okay? So it's actually right now it's 5 o'clock. How come it's only 8? I make some mistake. Okay, it should be 28 minutes, right? Minutes divided by 60. So here, let me put 0, okay? Why is actually correct? No, I think something wrong over here. Okay, let me see. So here, let me actually do fleet hour. So 5 hours. Let me see. Here, let me see. I think the time is wrong. Okay, the timestamp is wrong. So here I should have a timestamp, but I need to actually minus 7 times 360 times 24. I need to adjust for the time zone. Okay, I need to actually adjust for the time zone. I'm sorry, not like this. So I'm sorry, let me adjust this, okay, here, okay. So my timestamp need to be this one. Timestamp need to be minus 7 hour difference, okay. And then put my timestamp over here. And run it, okay. Let me actually save it, okay. This one is actually different. So here, let me actually bring my new timestamp again, okay. And how come it's still 5? Let me see. The timestamp, the hour would be the seconds divided by. Oh, this one is division. Okay, this one is division, not take modular. Okay. No. This one is division, integer division. Yes. So here, let's see, we have timestamp, and the timestamp divided by seconds. So that one is, this one is called day. So here I actually should take remainder. Okay. So here I should have something called days. This day would be the timestamp take division by 3600 times 24. Okay, I fixed my bug. Okay. So that is 0 hour. No, so let me actually don't do this one. Okay. I think that one actually the timestamp already is a Los Angeles time already. We see 32, 0.0 here times 10 to the 7. Let me adjust for the hour, okay? Right now it's 32 seconds. So now the second is correct, but the hour is wrong. Hour is wrong. We are 17:33, okay? Let me see, and it actually is 0 hours, so it's 24. So we need to minus 7 hours. So times 10 minus 7 hours. Minus 7 hours. 7 hours. Okay, so this is wrong, not a day. 7 hours. Yeah, okay, so the time correct now. So let me delete those unnecessary, this one, okay? And unnecessary data. Unnecessary data, okay? So here we have first one. This one is to do conversion of time zone, okay? Conversion of time zone. And here this one actually is the number of days since 01/01/1970, okay? And we do not need it, okay? And here is like this second should be seconds. It should be total seconds since this morning. This line over here I delete it, okay? This line over here I delete. And then this one is the hour. So this hour is actually number of hours since this morning, okay? And then this one is total seconds since this hour, okay? And this one is the number of minutes since the start of this hour, okay? And this one should be the total seconds since the start of this minute, okay? And then print things out, okay? So here these are the program called time.py. This one is similar to the change program, okay? So basically what you do is actually you get from the system time that actually is the total number of the seconds, right? I take integer, that would be total number of seconds. Total number of seconds since this time, January 1st, 1970, right? Then I minus 7 hours. That is a conversion of time zone. The conversion of time zone is because there is a Greenwich time and there is a Los Angeles time. It's a 7 hour away. So if you are Eastern time zone, like Joey and Ethan, here you should put 4, not putting 7. Hear me?
Yeah.
Hear me? That one you should put 4. And then for James and Heather, you should put 5. That you only 5 hours away from the Greenwich time. Is that okay? So let me actually post this one to you first, okay? So you don't need to type. Because this one is not a exercise, so I don't need you to type, okay? I give you the time.py file. Sam Helen, please actually also join as a friend over here, okay? Then when I post, I don't need to post 2 sites. And WeChat is going to be out of market soon, okay? Okay, so that's the time.py, okay? So now let me continue. That's adjusting of the time zone. So please use 4 for Eastern Daylight Time, and then use 5 for Central Daylight Time, okay? So that's the total number of the seconds from what? From that day, okay? And then I divide it by the number of seconds. That will become total number of days since that day, right? And then I take modular by the second per day. That will give me the total seconds since this morning, right? Since this morning. And then that's the total number of seconds since this morning. I divide it by number of seconds in hours. That will give me total number of hours since this morning. And then I take modular by that second in hour. I will get total number of seconds since this morning, this hour, the starting of this hour. Okay? And then I take modular by 60, I will get the number of seconds since the start of this hour. And then I take modular by 60, I will get the total second since the start of this minutes. And that hour, minutes, and seconds will be my current time. Is that okay? And this one, if you check, it will be the same as your clock over here. Is that okay? It will be the same as the clock over here. Is that okay? Hear me? Hello,
Yeah.
hear me?
Yep.
So that's actually, well, we're almost done here. Okay. So today we are mainly practicing this division, integer division. Okay. 2 problems we study. You have to study hard. Okay. 2 problems we'll study today. 1 problem is what? Is getting change. Second problem is the time conversion. Is that okay? And getting change, you already tried it. So what you need to do after class is please rewrite this getting our program. Is that okay? Time.py. Rewrite this time.py program. Okay? So I'll continue. Okay, I'll continue here. So there's a type conversion and rounding. Okay? So let's finish before mess the life. Is that okay? So let's look at this type conversion and rounding. Okay? So basically, you can convert the data type. Okay? And you can convert 5.0 to 5 using int, right? You convert 2 to 2.0 using float. Okay? You can convert that. Okay? And you can put a .0 that will also convert integer to floating point. Okay? So Python allow mixing integer and floating point. So it actually sometimes will convert by itself. So here floating point 22 divided by 5. This one will give you integer division. So integer division really means 22. 10 modular 22 divided by 5. You should get 4. 20 remainder 2, right? So this 4 will be the answer of this part. Converted to floating point, that actually change it to 4.0. Is that okay?
Yep.
Okay. So this one, integer 4.5, you will convert it to 4. Okay. Because 4.5, it will actually truncate this anything after the decimal point. 3.9 truncate this one. If you do wrong, you do rounding to 4, rounding to 3, rounding this by 2 digits, you will actually rounding to here. Is that okay?
Yup.
Yeah. And you can convert a string to integer. That will be 32 integer. Okay, you can convert 32 to 41. Okay, it's equivalent to the eval. Okay, but eval can convert to integer flow. Okay, integer can only convert to integer. Okay, so here we have this change.py, right? See here, it has change.py, but this change.py is different from ours. You want to convert the quarter times equal, but it's from string to number, and then take the sum of that. Okay. So you can also add this portion to your program. Okay. Once you get a quarter, nickel, pennies, whatever number, you convert it back to the total and see if it's the same with the original total. Okay. This one is called change.py. So this change.py is different from ours. Okay, that's finished. Okay, let's finish the portion. So here we have change.py. Okay, this one is different from ours. And it will give you enter these, you will get the number. So let's try this version of change.py. Not mine, but theirs. Not my version, but their version. Okay. So here I'm going to open to my code, and this textbook version of change.py, you can get it from my website. Okay, you can get it from my website. So here I have change.py. Okay, that's wrong here. So enter quarter. Let's do 1 quarter, 1 dime, 1 nickel, 1 penny, and 25 plus 10 plus 5, that would be 40. 40 plus 1 would be 41. So total dollar is $0.41. Is that okay? Is that okay? So my change version is actually from total number to number of dollar bill, number of quarter, number of dime, number of nickel, number of penny. And his change is actually converting from this side back to total. Is that okay? Hear me?
Yeah.
So please, today, please try, rewrite this one, and also get the time, rewrite the time.py program to convert the time. Is that okay? Trying to understand these two programs, and that way actually you will learn. Okay, you will learn a lot. So let me keep my time.py over here. Any question about this time.py? Any question about this time.py?
Nope.
So what actually did I teach today? Lori, what did I teach today? Using these two programs, what we really learned from here.
Integer division.
And the taking modular. Is that okay? And use that to two problems. One is getting change. One is conversion of time to the times from timestamp to what, to our time. So this one time.py, let me save as time2.py. Okay, let me try to save it as time2.py. So I actually changed to time2.py here. Okay, and then here actually, let me see, time2.py. I'm going to put this over here. I'm going to do while true. Okay, I'm going to do while true, and I just push this everything inside here. Okay, so actually here after I print, I'm going to do time that sleep 1 second. So sleep. Okay, sleep 1 second and then let's see. Oh, sorry. The logic true is not true here. Need to do capital, okay? Capital is like it's always true. Okay, good. This is good. Let me actually break it, okay? Let me break it, but I don't like to have the timestamp. So here, let me change terminology timestamp, okay? Save, and that's wrong. So what's that? So Joey, what's this? Hi Joey, what's this?
This is the time.
This is
Like
a clock,
every-
right?
Yeah.
It's a clock. Every second it tick, tick, tick a second, right?
Yeah.
So, I mean, a simple program like this, we can grab the system time. We can grab the system time from our computer. And that system time we grab from computer, every second, we calculate the time 1 times. Is that okay? Every second we calculate 1 time. Every second we calculate 1 time. About an hour, second, minute, hour, millisecond. Every second we calculate the hour, millisecond once. And then that becomes your clock. So that is actually how to write this project. What I'm demonstrating actually is to write, when we need to write to demonstrate the hour portion over here. See this one? Yeah. So this is the same as the one I have. This one is when we write along our time 2 program. This one is the clock. Is that okay? It's a simple clock from we getting it from our computer. Is that okay? James, is that okay? So let me actually also send you the time 2, okay? Let me also send you the time 2 P1, okay? And please study the division module, okay? And where to get the division module. This one I showed you before, maybe, I don't know. So here the Khan Academy has a whole course or whole chapter on this modular arithmetic, okay? We study that one. This one, I think grade 6, 7 should be fine with this one. The modular arithmetic is not too hard. For Helen, I would say it would be a little bit challenging. Is that okay? Yeah, well, so you need to try your best. Don't get frustrated, okay? This one is not really that easy, but try to understand it, okay? And today we basically teaching you the division and modulo 2 operator, okay? Using integer division. And it can be applied to calculation of the time for the day or getting judged, okay? Any question today?
No.
No? So we are about half of the chapter, right? Next time we study from MS library. Is that okay? So this today we mainly focus on modular math. Okay, modular arithmetic. Any question? Or if any one of you want to show me your program? Any question? Otherwise, we will stop here. Is that okay?
Okay. Thank you.
Okay, thank you. Bye bye now. Bye bye.
Thank you.
Bye bye.
Thanks.